Today's tutorial will be on segment tree. In the last tutorial, we have seen the basic operations of segment tree, and today we will see the initializing operation, updating operation, and the query operations of the segment tree. Now, moving on to our lecture. We have already seen these things, and we concluded here in the last class. So we already know that that in the segment tree, although it is represented as a tree, it's actually a conceptual tree. That is, the tree will be stored in an array. That's why in the pink color we have represented the indexes. That is, there will be 13 indexes in our segment tree array. Okay, and in that array, each of the positions will be representing a node of this segment tree. And again, each of the nodes actually represents a range. The leaf node actually represents a range where the starting and the end value of that range is same. That means it only represents a single value, but all the intermediate nodes represent the result of this query, that is the range minimum query on a particular segment. For example, this node represents the query for the range 3 up to 4. This node represents the result of the query from starting from range 1 to 7. In this way, we have seen the things. This is our original array, and another thing is we have also seen some formulas, that is how to find out the left child of a node. For example, for 8, the index number of 8 is 1. That's why the left child should be 2 multiplied by 1. That is, the left child will be found at this index, right? The index number 2 will be the left child, and right child will be 1 multiplied by 2 plus 1. That is here. Again, for this node, the parent index is 3. So left child will be available in 3 multiplied by 6 is 2, that is 6, and 3 multiplied by 2 plus 1, that is 7. Okay, and again, for any particular node, you can find the parent by just dividing the index by 2 and taking the floor value. For example, here for this index number 13, the parent will be 13 by 2, that is 6.5, and if I take the floor value, the index will be 6. Again, for index number 10, the parent should be 10 by 2, that is the parent should be found at index number 5. Is it the case? Yes, we can find it. Yes. So actually, again, we're saying that it's a conceptual binary tree, so it can be stored in an array. Now, my next question is, how can actually we build this tree? So to understand that, actually, I will show you an algorithm and also the process of, first of all, initializing a tree. And in the later videos, we will also show you that how to make a query in this segment tree or how to update this segment tree and what will be the complexity of each of the processes. Okay. So here, before building the tree, I have some observations. First of all, here, one thing that I already said that each of the nodes are representing a particular range. Okay. So amongst this range, how can I understand whether it is a leaf node or it is a intermediate node? So here, if we observe closely, so if we are talking about the leaf node, you can see that the beginning and the end index of each of the leaf nodes are same. For example, here, if I ask you a question whether this 0 is a leaf node or not, so I will ask you that what is the beginning index? You will say, okay, its beginning value is 6, the end value is 6. Okay, so what should I say? As the beginning and end value is same, so it should be a leaf node. One question is, here the range from 5 to 6 or 1 to 7, 6 to 6, what is this number? So actually this number is representing the original array index. Okay, so here if I am saying that so this tree was representing the sum query. Okay, so each of the nodes are representing the summation of within this range. So if I ask you the question that, okay, so 10, what does 10 represent? So if I say that, okay, the 10 represents a range from 3 to 4, and what is this 3 to 4? Actually, this 3 to 4 are the indexes from the original array. So here, so 10 represents the summation of the numbers of the indexes 3 up to 4. So what is the summation? So if I go to the original array, there is the input array. I will find that, okay, the summation is 3 up to 4. There are 2 numbers. What is the summation? 10. Okay, so it is represented by this number. Again, if I come here, so I have found out that, okay, 3 represents the summation from indexes 5 up to 7. What is this? Where does this index come from? This index comes from the original array. So here, if I go from 5 to 7 in the original array, I will find that 1 plus 0 plus 2, that is 3. So 3 is represented here. Okay. So another thing is here we are using one-based indexing. So so we are not talking about the index number 0. We will not use it. Okay. So our array is starting from index number 1. That's right. Now here, what the thing I was talking about is how can I detect the leaf nodes? So how can I say whether a node is a leaf node or not? So in that case, I need to find out the beginning index of that range that it represents and the end index. In the beginning and range beginning index and the end index is same, so it will be a leaf node. And for every other intermediate node, we will find out that the beginning and end is not same. So here we will need three. So when we are talking about the segment tree building process, so there will be three values necessary. That is, I need to first of all I need to locate that which node am I talking about. Then actually which node of the original array am I talking about? That is, am I try to build the which node of the segment tree array? That is 8 is so this node is representing using the index number 1. That is, these are node number 1, this node number 2, 3, 4, and so on. For example, 1 is node number 12 of the segment tree array. That's great. So three things will be necessary. First of all, which node does it represent? Then what is the beginning value and what is the end value that is of the range that it represents? Afterwards, if I come here, so this node, so this node, if this node is empty, so how will I understand what value should come here? So actually, if I check it, this 8 is actually the summation of the left subtree and the right subtree. Actually, the summation of the left subtree is present here. So in this node, there is this index number 2, there is this 5, and this 3 actually summarizes the summation of all the numbers within 1 to 4. That is the left subtree and the right subtree. So there is a dependency here from node to node. That is, when I am talking about a particular node, before computing this node, the left and the right child should be present, because here as I am talking about the summation query, so here this node will represent the summation of its left and right child. Okay, so here what is happening here? So if I summarize that, to find out the value of the index number 1, I need to find the indexes the values of its left and right child. Okay, so again, if I am talking about this index, to find out this index, I need the value of its left and right child. Again, to find out this index, I need the value of its left and right child. But here, when I'm talking about this index, why don't I dig further? Because this node is a leaf node. And how do I detect a leaf node? By seeing the range that it represents, that is the beginning and the end is the same. So here, in this way, I can move on. So here, so this should be a bottom-up approach. That is, I need to calculate the nodes in the beginning. Okay, so I need to calculate the nodes in the beginning, and after that, so by combining each of the two nodes, I can find out the upper node and upper layer, and in this way we can proceed. So we have already got some ideas about how we can build this tree. So just to summarize the point, first of all, we have some observation, that is each of the leaf nodes. So actually, so in the segment tree array, there are 13 indexes, but in the original array, there are only 7 indices. So the question is, in which node will these values go? Or in which position? So my answer was actually only the leaf nodes will contain the values from the original array. Okay, so that's observation number 1. Another thing is, all the intermediate nodes will be the result of the query of its left and right subtree. As I said, the root node, how did I get the root node? We find out the result of the query for the left child and result of the query for the right child. So it's 5 and 6, so together it makes 8. Let's say if I was talking about the minimum query, okay, so if I was talking about the minimum operation, in that case, so here we have just added the two values. If I'm talking about the minimum operation, I will take the minimum of these 2 values. Or let's say if I'm talking about the maximum operation, so 5 will come here. If I'm talking about minimum operation, 3 is coming here. 3 will come here. As I'm talking about the summation operation, so 5 plus 3, that's 8, that is coming here. Okay. So this is another operation. So here actually, when I'm talking about the max segment tree, so in that case, max of the segment will be the max of the left subtree and right subtree. That's why before building the upper levels, actually I need to find out the values of the lower one, because they are building the so we need to go from bottom to the top. There is a bottom-up approach. Okay. Afterwards, there are some other observations, that is, before finding out the values of a particular node, I need to find out the value of the left and right children. And another thing is, how can I detect the leaf nodes? So I have already said that the beginning and the end indexes will be same, and but for all of the nodes, they are intermediate nodes. How can I find out? Because for them, begin will not be equal to the end, and that's why I need to find out I need to perform some calculation. Okay. So before going to the algorithm, just to summarize, so if I talk about this tree, what will I do? So first of all, I will show you a recursive algorithm. I will show you the recursive algorithm for building this tree. So here, what's actually happening? I will start calling a function that is called init. Okay. So moving on to the algorithm. So here in the main function, let's say I have 7 elements. So all of the elements are added in array ARR. That is, this is the input array. So and I have a function that is called init. Init means initializing the function. So here I am trying to, so as I said earlier, there will be 3 parameters for the function. And here, first of all, the first parameter represents which node I am talking about. Second parameter represents the beginning of the range that the node is representing. That, for example, here the first node, that is the root node. So this one represents the first index of the segment tree array. So in that case, the first index, that is the root node, represents the range from index number 1 to index number 7, as I have 7 elements. So that's why I give 7 as 1 as the begin and n as the, that is 7 as the end. Okay. So the 3 parameters are representing, first of all, the node that I'm talking about. So as I'm talking about node, that means I'm talking about the segment tree array. And another thing is, where does, so this node represents a range. So where does the range begin and where does the range end? Okay, so first of all, for some case, for any particular case, if I find out that beginning is equal to end, that means I have reached a leaf node. So I have reached a leaf node, and that's why what will happen. So in that position of the tree, so here by the term tree, I'm representing the segment tree array. Okay, so here the tree is representing an array which will store the nodes of the segment tree. Okay, so in that position, I will take the value from the original array and put it in the tree, because begin is equal to end. So as I said earlier, only the leaf nodes will hold the values from the original array. But if this is not the case, what will happen? In that case, I will need to find out the value. So if begin is not equals end, that means it is not a leaf node. So that I cannot find out, I cannot bring the value from the original array. Rather, I will need to make some calculation. Why do I make that calculation? So actually, because if begin is not equal to end, I will need to add my left subtree plus my right subtree. If I was talking about minimum subtree, in that case, I will take my left. So I would take my left child and right child and take the minimum value. Or if I was talking about the maximum subtree, maximum segment tree, in that case, I would take the left child and right child and take the maximum value. But here, as I'm talking about the summation operation, so I need the left child and right child. So here, what will happen? I need to find out the value of my left child and right child. So as I'm not a leaf node, because leaf node doesn't have child, so for leaf node it will be true. But otherwise, I need to find out my left child and right child and make the division. Here, another important operation is in our image. What happened is I made some decision. This portion will be from 1 to 4 and this portion will be from 5 to 7. Actually, how did I take this decision? Actually, I divided this original array into 2 portions. That is, I calculated the mid in the beginning. So I calculated the mid of the array. So I gave the index from begin to mid in the left segment and from mid plus 1 to right in the right segment. For example, here I have indexes from 1 to 7. So if I find out the mid, the value will be 1 plus 7 divided by 2. That is, the value is 4. So the left segment will represent the values from, that is, the left subtree will represent the values from index number 1 up till the index number 4. And the right subtree will represent the values from range mid plus 1 to the end. That is, here the end is 7 and mid plus 1 is 5. That is 4 plus 1, that is 5. So this range will be representing this value again. So when I'm talking about this node, what happens? I needed to find out the value of its left subtree and its right subtree. That is the left child and right child. So that's why I needed to make a division. When I'm talking about the division will be based on this node. So this node represents the values from index number 1 up to index number 4. So how can I make the division? For making the division, I need the value of the mid. So how can I find the mid? That is left as a beginning plus end divided by 2 and take the floor value. So here 1 plus 4 divided by 2 is 2.5 and the floor of 2.5 is 2. That means the mid is 2. So the left segment will have the value from index number begin up to index number mid. That is index number 1 to 2, and then the rest of the segment will be index number mid plus 1 until 10. That is 3 until 4. Okay. So if you check this out, you will understand. So here, so when begin is not equal to end, that means I need to break the tree further into left and right subtree. So what will happen? So that's why I need to find out. So to make the division, I need the value of the mid. So what is the value of the mid? So begin plus n divided by 2, and I'm taking the floor value. The left and the formulas of left and right subtree is here. Right child is here. Then what will happen? I will try to call the initializing function based on my left subtree and the right subtree. Okay. And finally, the position of my so in the position in the node position, the value of the left and right will be added. Okay. So if this is not clear, let me move on to some demonstration. I think the idea will be clear. Okay. So here. Okay, so if I'm talking about if I'm calling my function for my original array, so let me check it out. I'm using Microsoft Whiteboard. Okay, so this is my original array. Okay, so this is my original array, and I have index number 1 until index number 7, and in my segment tree array, in the beginning everything is empty. So I need to fill it out step by step. Okay, so after that, if I'm talking about if I'm calling the initializing function, so what's happening? So in the beginning, so let's call the function as f. Okay, so I'm calling function as node number 1, then node number so the beginning is 1 and the end is 7. So I'm calling based on the original array. Okay, I'm just copying it for. Okay, so I will draw some more nodes here. Okay, so in the beginning, this will be called. So what will happen? So in the beginning, the begin is not equal to end, right? So what will happen? I will calculate the left, right, and the mid. Okay, so for this operation, what is happening? The value of left child is the node is 1. So 1 multiplied by 2, that is equal 2. And the value of right will be 1 multiplied by 2 plus 1. That is, the right child will be 3 and mid will be 1 plus 7, that is 8 divided by 2. So the result will be 4. Okay, so just taking it aside. How can I take it in the other side? Right? So irritating. Where is the select rule? How do I take it? The other side. Right. Oh, finally I succeeded. Yeah, congratulations. Now, make it in another color. Here, what is happening? So, according to my code, if I take the code here, just a second, let me capture the code and take here. It will be easier to understand. Okay, yes, this is the code. Okay, so here what is happening? If I am talking about it's difficult to mark it. Why can I? Oh, okay. Okay. So first of all, what will happen in the beginning? I need to call the init function. So I have called the I'm representing init by f. So what is happening? The node here is what? Node here is 1. Okay, so I'm trying to find out the value for this node actually. Okay. Afterwards, the begin and end is 1 and 7. So in the beginning, begin is not equals n. What will happen? So here, this line number 2 up to line 5 will not be calculated. Okay. So afterwards, so I need to calculate the left, right, and mid. So I have done it here. Afterwards, what is happening? I need to call the init function based on line number 9. Okay. So I first of all to find out the value of 1. Actually, I need the value of the left and right subtree, left and right child. That is, I need the value of index number 2 and 3. That's why I'm calling it in a recursive fashion. That is, first of all, I will be trying to calculate the value of index number 2, and afterwards I will be trying to calculate the value of index number 3. That is the left and right child. So I am stuck in line number 9 here. Okay. So just try to keep track. Okay. Yeah. So I'm taking it here. So my calling will be, first of all, I will be trying to find out the value based on the left segment. That is so for which node am I calling the function? I'm calling for node number 2. That is the left child of this the parent. Okay. Then the node will begin at the index number begin of my parent. So what was the begin of my parent? That is 1. And what is the end of what should be the end of myself? That should be, so according to line number 9, you can see that it should end at mid. Okay. So here mid is 4. So this function will be like this. Okay. So if I draw the line here, so from here there will be a this one. Okay. So again, so what is happening here? So this node is now in a pause situation. Okay. So I'm saying that, okay, so this is in under a pause. So what's happening? So I'm trying to calculate this node. So I'm trying to calculate this node. Okay. So when I'm trying to calculate this node, again this function is called. Okay. So this is the concept of recursion. So when this function is called, what's happening here? So here now the value of node is 2. The begin is 1 and end is 4. So again, this condition is not satisfied. That means, why is this not satisfied? So actually, we can see from my original array. So from my segmentary array is all the values are empty, and I said that all the nodes have some dependency based on its children. So here for this node, the children are not actually calculated. That's why I'm facing some problem. So what will happen? So before calculating node number 2, I need to calculate the left and right child of node number 2. So so again, so here what will happen? So I need to make some calculations again. So here, what is happening for this node? For this, okay. So for this node, what is happening? I need to again calculate the left, right, and the mid. So if I'm talking about the left child, so previously it was 1. Now, as I'm talking about this node, so the left child will be found at index number 4. The right child will be found out at index number 5. Make it a little bigger. Okay. So and what will be the mid value? Here the beginning is 1, but the end is 4. So the value is 2.5. And if I'm talking about the floor value, the value will be 2. Okay, so for this stage, this is the value. So what will happen here? So I have calculated the node number. So the line number 6, 7, and 8 for this function. Again, I'm stuck at line number 9 because to calculate the value of this function, I need to calculate the value of my left and right subtree. Okay, so so before calculating the right subtree, I need to calculate the left subtree in the beginning. So that's why there will be again a recursive call. Okay, so I'm putting it here. So here, when I'm talking about this call, what will happen? The call will be based on my left child, and the range will be from begin to mid. So here my left is 4, and the begin here is the same as the begin of my parent. So the value will be 1. But what is my mid here? My mid here is 2. So this is the case. Okay. So from this node, I am coming here. Great. Afterwards, what is happening? So for this node, again, I will take a fresh copy of my this function. Actually, to understand the concept of segment tree, the concept of recursion is very important. Actually, whenever we are talking about advanced algorithm, recursion solves the problem very well, but to visualize the recursion is a bit difficult. So actually, I'm showing the operation of the initializing function in detail, but it takes a lot of time to explain each of the steps of the recursive function. So my earnest request will be for the students, whoever watches this video, to check to practice it by yourself again and again, so that you can understand all the intermediate steps of the algorithm. Otherwise, it's very difficult to visualize. Okay, so here so again, so I was working with this copy, but what happened? So there was a pause here. So I'm again talking. I'm now here. Okay. So when I'm coming here, what's happening? I have a fresh copy of this function, but again, begin is not equals n. So what do I need to do? I need to calculate line 6, 7, and 8 for this function. Okay. So what is happening here? So here the node number is 4. So the left child is 4 multiplied by 2, that is 8. And what about the right child? Right child is 4 multiplied by 2 plus 1, that is 9. Okay. And what about the parent? So what about the mid value? So here the range is from 1 until 2. So 1 plus 2 is 3. So the value will be 1.5. And if I'm taking the floor value, it will be 1. Okay. So line 6, 7, and 8 is clear. But again, so if I'm just to remember, here this function was stuck at line number 9. This function is stuck at line number 9. This function is again stuck at line number 9. Right. So I'm showing it in the best possible way. I hope everyone understands this one. Okay. So this function is stuck at line number 9. So what should I do? I need to call the initializing function again, because begin is not equals n. So to calculate node number 4, I need the node number 8 and node number 9. That's correct. So what should I do? So here from this function, I need to call the initializing function again. So how will the call look like? So if I just take it here. So here, so for which node am I calling? So I'm calling for the left child of the node 4. So what is the left child? I can find it from here. The value is 8. Okay. And where does the index begin? So actually the range is from begin until mid. So here the begin is same as my parent. But what happens? My end is something like the end is my mid value, right? So here my mid value is 1. So I will stop here. Okay. So actually this function calling is from this node. That's great. But what is happening? As I have called this function is again in the pause state. Okay. So I don't know whether this should this be like this. I'm confused. But I think the idea is clear. Okay. Let's just not talk about the symbol. Okay. So here now we have a good state. What is happening? So for this node, what has happened is here I have found it as this condition is satisfied, right? So this condition is satisfied for this function. So that's why I don't need to calculate any further nodes for this function. Rather, what will happen in the tree array? So actually this is our tree array. Okay, so this is the tree array. So in this array, what will happen? I will just put the value of the array begin. Okay, so here what is the begin? So begin is 1. Okay, so and what is the node? Node is 8. So in the 8th position of the tree array, I will put this value. Okay, so again, so what will happen? So I'm just cutting this value. Okay, so I have finished this one, and I can write 4 here. Okay, so index number 8 is done. Index number 8 is done. Okay. So index number 8 is done, and when it is done, so I can just cut it. If I change the color. Okay. So how can I remember? Okay. So this function is finished. Okay. So if you can understand, so as I have inserted the value for this function, so I'm finished now. Okay. So I'm not doing any further division, because left is equal to right. That is begin is equal to n. That's great. and we can already see the progress here. So one value is inserted here. Okay, so moving on. So now what will happen from this node, I will come back to my previous state. This is the idea of the recursion. Okay, so from this node, I am coming back to my previous state. And what's happening here? So previously it was stuck at line number 9, right? So we already remembered that this function was stuck at line number 9. So what will happen? I will just cut this line and I will try to move further for this function. So for this function, what will happen? I will come to line number 10 and again I am stuck. So what will happen for the, so again there will be a function call, because for node number 4 I need two values, that is the my left child and my right child. So what is happening here? So for this node I need to calculate this node number 9. So according to the formula, the function call should be just let me write it down. Okay, so if I'm trying to write it, so actually the function call should be for my right node. Sorry, what is the value of my right? Value of my right is 9. Okay, so 9, and then what should be the range? So the range should be from mid plus 1 to the end position. Okay, so what is mid plus 1? So for this one, the mid value was 1, right? So the mid value was 1 for this node. So what would happen actually? Here mid plus 1 is 2, and what is the end value? So the begin and the end value comes from my parent. So what is the parent? So the parent is this one, and the value is 2. So what will happen? I will put 2 here. That's great. And actually, if I draw the function calling, here I am coming to this node, and if I want to remember, the state, what would so actually I am now stuck at line number 10. Okay, so I am now stuck at line number 10 for this function. So I'm coming to this value. What happens there is actually again line number 2 is satisfied. There is begin is equal to end. So I don't need to make some further division. Rather, what will happen? I will put the value in index number node in the segment tree. Okay, so this is our segment tree array. So what is happening here? So here my position, there is the node is 9. So I'm coming here. Afterwards, what is happening? So the value should come from the begin of the array. Actually, it can also be end, because begin is equal to end, right? So I could also write array end. So that's not a problem. So what will happen? So this value will come. So I'm taking -9 here, and -9 has come here. So the execution of this function, is finished. Okay, just let me cut it down. Okay, so the execution of this function is finished. So again, so what will happen? So from this one, I'm coming back to my parent. Okay, so I have come back to my parent. So here, what was the state of my parent? My parent was stuck at line number 10. So my parent, so this function call will try to move further. So what happens from here is, I try to call line number 11 from this function. Okay, so from this function, so what does line number 11 tells us? So line number 11 tells in the node position, that is, which position am I talking about? I'm talking about now this position, that is index number 4. That is because it's the 4th node of my tree. That's right. Okay, so the value should come from the tree left plus tree right. So here, what was my left? So for 4, the left was 8 and the right side was 9. Are they present now? Yes, because we are talking about bottom-up function. So we have already solved our bottom position, that is, the dependency is already solved. Okay. So what should be the summation? So it is 4 plus -9. So it is -5. Okay. So already we can see that our array is getting filled. So here, so previously our position was we were stuck at index number 10. So now we are this problem is solved. And another thing is, so what will happen? So line number 12 is just the finishing of this function. So here we can just cut this function out. So this function execution is finished. Okay. So so this function is now, so this pause state is now finished. Okay. How to cut it? Okay. So I'm actually new to this environment, so it's taking a bit time. Okay. So here from this one, I'm coming back to here. So I'm coming back to my parent. But again, when I came back to my parent, what I see, I can see it there. That is, my parent was stuck at some point. In which line? In line number 9. So this was the line. So this line is already solved because as I have come back, so this line number 9 is solved. So I start to continue again. Okay. So I'm starting to continue again. But when I'm trying to continue, what's happening? Okay. So here, so I should call the line number 10 for this function. So just to calculate the left and right for this node. So for this node, so as a node is 2 here. Okay. So the value for node is 2. So it was, just to recap, it was 4, and the value of this one was. So I think you have already got the thing. So I will finish this tree, but my request will be you should try by your own. So it was 2.5. Okay, so we have finished it. Now the function calling should be based on a. Okay, so just to finish the function calling, here what is happening? So I need to make the function call based on my node. So previously the calling was my left child, now it will be my right child. What is my right? Right is 5. So 5, then my, so previously it was begin until end. Now it will be begin until mid. Now it will be mid plus 1 until end. So what is mid plus 1? So previously my mid was 2. So the range was 1 to 2. So it will be now 2 plus 1. That is, the value will be 3. And how long should I, so what will be the length of the range? So it will be end. So what is the end here? So end will be coming, begin and end. These two values comes from my parent. Okay. So it is coming from my parent. That's great. And so, okay. So it has come from my parent, but again, my parent is stuck. So my pause condition continues, and I'm now stuck at line number 10 for this function. Okay, now moving on. So for this function, again, I need to start a new copy for this one. Okay, so I will not edit these values now. So what's happening here is, okay, so for this node, again, so what is the value of the left? So the left children for 5. So why cannot I calculate this node? Because the left and right nodes are empty. Okay. So what should I do now? So I should try to call my the left node for this one. Okay. So what is the left child of 5? The left child of 5 is 10. So what should be the length? 10 should be from begin until mid. So what is begin here? Begin is coming from the parent. So 3. And what is end here? So end is actually 3 plus 4 divided by 2. So there is 3.5 and the float value is 3. Okay. So this is the value. So we have already seen the value. And so what will happen? So the function call is from here to here. And it will be now in the pause state. And it is now paused for line number, what? Line number 9, right? Okay. So it is now paused for line number 9. Now, when I'm talking about this one, so this function call is done. Now, when I'm talking about this one, what is happening? So for this function call, I am now stuck at line number 2 because line number 2 is begin equal to end. So begin equal end is satisfied. So what will happen? The value from the original array will come to the segment tree array. That is, this value, that is index number 3, will come to index number 10, and the value here is 3, right? So from the value from the original array is 3. Okay, and this function call is finished, and this comes back to my original array. Okay, so previously it was stuck at line 9. What will happen now? It will make another function call. So it's making another function call, and the value of the function call will be my right child. So the parent is 5, so the right child should be 5 multiplied by 2 plus 1, that is 11. So mid plus 1 is 3 plus 1, that is 4, and the end value is 4. Again, we have satisfied our condition, that is begin equal to end. So here the value will be going to my original array. So here it is now stuck at line number 10. But what is happening here? So this one is satisfied. So from the fourth location of the original array, the value will come here. So this is, I should cut it down, and 7 has come here. Okay. 7 has come here. Okay, and this function call is finished. So as this one is finished, what is happening? It is returning to my parent. Okay, and my parent is in a stack is stuck at line number 10. Okay, so now what will happen? So it will try to move on, and what is happening here? So in line number 11, we can see that the value. So for this function call, everything until line number 10 is finished. So I should calculate line number 11. The actual line number 11 calculates the value for this node. So this node is line number, this node is index number 5. So the value should be the left plus right. So what is the value of this one? So the value is 3. And what is the value of the right sub 3? Value is 7. So 3 plus 7 is 10. Okay, so actually, as this is the intermediate node, the value is not coming from the original array, rather it is calculated from my segment tree array. Okay, so it is the result of the range minimum query on this node and this node. Okay, so I hope the concept is clear. Okay, so I will try to speed up now. So what is happening? This one is finished. So afterwards, after move on. So as this one is finished, so now I will come back to this position. So this position was actually hold at line number 10. Okay, so line number 10 is now satisfied. So what will happen for this node? I need to calculate index number 11, line number 11. And what does it say? It tells us to calculate this node. That is node number 2. And so to calculate this one, I need to calculate the value of 3 left and 3 right. So what is 3 left? So at position number 4, we can see that the value is -5. And position number right, that is the node is 2, so the right position should be 5. So it is 10. So 5 plus -10, that will give us the value as +5. Okay, so this one is also finished. Okay, so this function call is also finished. Now what will happen? So this is done. Now I am coming back to the base function. Okay, so again here, what will happen? So from here, I need to calculate the right child again, because this is stuck at line number 9. So now everything until line number 9 is calculated. So I should start line number 10 for this function call. Okay, so I hope if you understand this one clearly, your concept of your overall concept on recursion will be very clear. So it is worthy of your time. How can I make it bigger? I can't find it. Okay. What is bigger? Now, what is happening? So for this function, I'm trying to call the line number 10. That is, I need to call my right child. So what should be my, so just before coming here, so whether is our calculation correct? So here in index number 2, we can see 2 and then index number 4. So just to make match the value with our previous tree, if we check, so in index number 2, the value was 5. Index number 4, the value was -5, and index number 5, the value is 10. So if I just match it with here, so we can already see that the values are same as the actual tree. So we are going to the right process. Okay. So here, so for node number 1, the right child should be what? So we have now we are not bothering about this calculation anymore. We just as we are habituated. Now I'm trying to speed up the process. So for this node, the value is for this node, the right child is 2, and the range should be mid plus 1 until end. So the value of the mid was 1 plus 7 by 2, that is 4. So the mid plus 1 should be 4 plus 1, that is 5. Okay. So here again I'm stuck for this function call. So here now I am stuck at index number line number 10 here. Okay. And from this node I have come to this one. But again I have faced a problem. That is, this node is not equal to the, so the begin is not equal to end. That's why I need to dig further. Okay. So if I'm talking about this one, Okay, so I need to make a function call for my left subtree. Okay, so I'm running out of space here. Okay, I hope this will work. Now, what is happening? So for this one, so what is the left child of? Okay, I have done a mistake. This should be the right child, right? So it will be 1 multiplied by 2 plus 1. That is 3. Okay, so for this node, what is with my line number? So for this one again, I need to calculate the line number 6, 7, and 8. So and make the function call for the left child. Okay, because for index number 3, the left child is 6 and the right child is 7. So both of them are not present. That's why before calculating index number 3, I need to calculate index number 6 and 7. Okay, so what's happening here? Let's wait for the Azan to finish. So we are talking about the left children of this node. So 3 multiplied by 2 is 6. So the value will be 6, and the range will be from index number begin to mid. Okay, so what is the begin from the parent? So the begin is 5. Okay, so begin is 5, and what is the mid? Mid is 5 plus 7 divided by 2. That is 12 by 2. That is 6. Okay, so this is the function call from the parent, and actually it is again in pause state at line. So it is in pause state in line number 9. Okay, so I will not try to calculate this one, but to calculate this one, what's the problem? Begin is not equal to end again. So what should I do? I should try to calculate this one for the left and right subtree. That is, I need to initiate line number 9 for this function call, and then line number 10. So to do that, again, I need to. So I think I'm running out of space here. Okay, so I have space now, and this function call is coming. Okay, so moving on. So for this one, what is happening? I need to make the call for the left subtree as begin is not equal to end. So for 6, and from the original array, I can also see so these two values are not equal. So for 6, I need to calculate the index number 12. And for index number 12, the begin value will be coming from my parent. That is, the value will be 10, and mid value is 5 plus 6 divided by 2. That is 11 by 2. That is what? Okay, I'm doing a mistake again. So this value is begin. That is 5, and mid value is 5 plus 6. That is 11 by 2. That is 5.5, and the float value will be 5. Okay, so you can see some improvement already. That is, so the value is coming from here to here, and this is in the pause state. Okay, so this is in the pause state at line number 9. So what is happening? I need to calculate this one, but when I'm trying to calculate, so I can see that begin is equal to end. So the value will come from the original array. So what is the value at index number 5 of the original array? It is 1. So 1 will come at node number 12. Okay, so 1 is coming here. Okay, and that's fine. And after, if this is done, so I have no further line for this one because I need to calculate. So at line number 5, it will return to the main function. Actually, the previous state, that is this one. So this will be done, and I'm coming back to here. So this is finished. So now I need to initiate line number 10 for this function. So here, what is the line number 10? The line number 10 is I need to calculate it for the right children. Okay. So what is the right children here? So the right children will be what is 6 multiplied by 2, that's plus 1, that is 13, and the range should be from mid plus 1 until end. So what is mid? What was mid? Mid was 5. So mid plus 1 is 6, and what is end? End value comes from the parent. So parent is 6. So the value is 6 here. Okay. So again, my state is in stuck. Okay, and it's stuck at line number 10, and the value is coming here. But the good news, that is the begin is equal to end. So what will happen? The value from original array, that is in index number 6, will come to the segment tree array. Okay, so the value has come here, and this function call is finished. As this is finished, I am coming to here, and when I'm coming to here, you can see this was stuck at line number 10. So line number 10 is finished. So what will happen? So line number 11 will be calculated. That is, the value will be what? The left plus right. What is the left of 6? 1. What is the right of 6? 0. So that's why the value will be 1 here. Okay, so I think the idea is clear. Okay, so moving on. So I need to clear up some space here. Okay, moving on. Here, what was happening? Previously, my left child was this one. So this one is fully calculated. So I can come back to my previous state. That is this one. But for this one, the left child is already calculated. That is for 3, 6 is calculated, but I need to calculate 7 again. So that will be the last step. And so moving on. So I will try to calculate. So what is for which node shall I calculate? 3 multiplied by 2 plus 1, that is 7. Okay. So what is the range? That is mid plus 1 until end. So what is mid? Mid was 5 plus 7 by 2, that is 6. So it will be 7. And what is the end value? End value comes from the parent. What is the end value of the parent? 7. So the value will be 7. And again, so this comes here. Okay. And this is it is again stuck at line number 10. Right. So before calculating this one, so I need to calculate this. So when I'm talking about this one, so as begin is equal to n, what should happen? The value should come from the original array. So this 2 will come here. Okay. And finally, so this function call is finished. I am coming back here. This one, what should be the value? So everything until this one is calculated. So I need to calculate line number 11 for this node. Okay. So just this one will finish. So what is happening? This will take the value as left plus right. That is 6 plus 7. So the value will be 3 here. Okay. So the value will be 3. And finally, our last node, that is index number 1. So what should be the value? The value should be the coming from the. So actually now everything so we did everything for this node, right? So actually, as this one if in the beginning for this node begin was equal to n, we will just stop. But we did this whole tree. So all this 20 or 30 minutes just to solve this node. Now, so this node was previously stuck at line number 10. Okay, so this subtree is finished. This subtree is finished. So what is remaining for this one? Actually, if we look closer, so we will find that the line number 11. Line number 11 is just left for this node. So what is the line number 11? Line number 11 says us to add the left and right child. So okay, I think I mistakenly okay. So this value should be 8. Okay. So this is our full segment tree. And I hope you understood the process. And if you want to draw the tree, so what is happening? So let me draw the tree and finish this demonstration. Then I will go back to the slide. So here the value is 8. Okay. So what is the left child of 8? It is 5 and 3. Again, what is the left child of 5? Left child of 5 is presented in index number 4. That is -5. And what is the right child? The right child is 10. For 3, what is happening? The left child is 1 and the right child is 2. Okay. Then what's happening? This is 1. For -5, the right child is 4 and so left child is 4 and right child is -9. Okay. For this node, for this 10, the left child is 3 and right child is 11. Okay, sorry, 7. And finally, for this node, index number 6, the left child is 1 and the right child is 0. Now, this is our segment tree. Okay, this is the segment tree. If you match it with the original tree, so you can find it out whether it matches or not. Okay, so here it will, if you match these two things, you will understand this one. Okay, and I tried to make a demonstration based on the stack implementation. Okay, so this whole tree is actually, although I tried to demonstrate it using a tree approach. Okay, although I tried to demonstrate it using a tree approach, actually in the there is the actual process of recursion is maintained by the system using a stack that is called the recursion stack. Okay, so if I try to show you the demonstration using a tree, and also let me just finish it with the stack implementation, and then this lecture will be finished. And in the next lecture, we will find out the query and the update operation. So if we are talking about, so if you have understood the tree, this whole implementation will be very easy for you. So I'm doing the same thing, just maintaining, I'm trying to maintain a stack. So in the beginning, I was trying to, so to understand this one, just let me clear out some values from here. So this was the actual demonstration. Okay, so I think it's clear now. Now, if I am moving on to my stack implementation, so we begin. What did I do? We started with this node, right? So we started with this node. So actually, this will go in the recursion stack in the beginning. Afterwards, so as begin is not equal to end, it will call another line. So that is actually I did some change in line number. So the line number will not be same as this code. Just I think I avoided these spaces in this code. Okay, whatever. So if you follow this algorithm, this is the same algorithm, just the line number is different. The line number will match. So actually, I need to call this one, right? So actually, this one will come in the stack. So when this is so, and always the top of the stack is satisfied. So what is happening? So when I'm working with this one is in the stack, but it will not be satisfied. This will not be processed now because I have something else in my stack. And previously I said it using some pause. So I showed this diagram, right? The pause is this. Actually, why does the pausing happen? Because always the top of the stack is satisfied. That's why all these things will be in the pause state. And here I have showed it using red color. Okay. Afterwards, so from this line, I need to move on to this line, right? So because when for a particular node, if begin is not equal to end, first of all, what do? I calculate the left subtree and then calculate the right subtree, right? So what will happen for this node? I need to calculate the left subtree. So let's calculate the left subtree. But again, this one will again start at a particular line because left is not equal to right. So for this node, and this will be in the pause state. So currently this will be handled, and all of these two will be in these two will be stuck, right? These two will be stuck. So actually, we can already see that this two is already stuck because these two are already stuck because there, in the top of the stack there is something else. So this node will be satisfied now. Then when I'm talking about this node now will be in pause state. Okay, so this one will pause, and I will try to calculate this node. So now the top of the stack will be changing. So this one is coming here. Now what is happening as begin is equal to end, the value will come to the original array. Okay, so this value is updated, and this is the same procedure as I showed using the tree. So both of the processes are correct. So actually, just showing you that it can be done in two ways. Okay, and this is actually the way the stack is actually maintained in our computer to solve recursion. Okay, and these slots are actually some positions of the memory. You can visualize it like that. Okay, so moving on. So when this one is satisfied, I'm coming back to this one, right? So currently the top of the stack was this one. So based on this one, the value is clear. So I'm coming back to the previous state. So when I'm talking about this one, what will happen based on this value? I need to calculate the right child. So the top of the stack is 922. So as left is equal to right, so the value will come here. So okay, so the value has come here. Now what's happening? So when these two things were finished, now I need to finish this function call, right? So when so for this one was stuck because my left and right was not present. But now as my left is finished and right is finished, what should I do? I should come back here and calculate this one. So how do I calculate? I just add left and right. So here left plus right is equal to -5. So the value has come here. So when this is finished, so what should I do? I should come back here. So if you see, so actually 412, that is this 412 is finished. So what should be the next call? Next call should be 534. So we can see that the value is 534 and 214 is actually waiting in the stack because the top of the stack is this one. So again, for this 534, as left is not equal to right. So what should I do? I should go to my left and go to my right because I need this one. Okay. So moving on. So based on this one, the next function call should be 1033. So this 1033 and as begin is equal to end, so this location will be updated. Afterwards, I will calculate this position. Okay. So as again begin is equal to end, I will find so I have called 1144 and again here this function call is satisfied. So begin is equal to end, so the value will come here. So we have already finished. So as these two things are finished, I need to finish this 534. And how do I finish it? I just add the left and right subtree. Okay. So the left hand side is 3 plus 7. So the value 10 has come here. Okay. So just to add another thing, that is what was it? Okay, I have forgotten what I was saying. Moving on. Okay. So here, so as this one is finished. Okay. So this one is finished. So now this node is ready. So 214 will be served. Okay. So all of these lines are now satisfied. So I should come back. So the top of the stack will be clear. And now I can come back to 214. Okay. So what's happening? When I'm trying to calculate 214, this 5 is actually coming. Okay. Just this 5 is actually coming. So the value of this node is finished. Now for this node, what is happening? So for 117 cannot be the top of the stack because I need to calculate my right subtree again. Okay. So the whole procedure will be followed for my right subtree. So just to finish it, so 357 will be called, but again left is not equal to right. What should I do? I should call 656. Okay, 656, but again left is not equal to right. So what should I call? I should call this 1255. So 1255, when I'm calling 1255, actually 1255 means node begin and end. Okay. So the value will be coming at this position. Okay, so the value has come at this position and the next function is 1366. So the value has come at this position. So this one and this one is calculated. So I'm coming back to here. So this value should be this one plus this one. So 1 plus 0 should come here. So this should be 1. Okay. So 36 is equal to 312 plus 313. So I think this is clear. And the thing I was trying to mention that is here I'm adding the left and right subtree because I'm talking about the sum query. But if I'm talking about the minimum or maximum query, what should I do? In this case, I would take the maximum between these two values, or I could also take the minimum between these two values. This is based on the type of segmentation that you are trying to make. Okay. So afterwards, so this one is finished. So for this one to be satisfied, I need to calculate this node, that is 777. So I will make a function call that you can see it here, 777. So for this node, so as left is equal to right, the value will come from the original array, that is this 2 will come here. Okay, this is finished. So this node is finished. So I can calculate this one. So the left plus right. So this value will be 3. And finally, so as everything is finished, this node now can be calculated. Okay. So T1 is 2 plus 3. Okay. So this one is also finished. And as everything is finished, the whole tree is filled. So this function is satisfied, and it will come back to the end function. So this was all about our initializing a segment tree. I think actually the lecture is a bit bigger for this small topic, but my objective was actually two things. That is to demonstrate you how this concept works. Also, I spended a lot of time in explaining how recursion works. Actually, recursive algorithms will come again and again, so it's better that you understand it properly. So most of the advanced algorithm uses those things. And what will be the complexity? Actually, here if we're talking about this thing, so if I show you the original tree, so we can see that this is a binary tree, right? So we already know that for a binary tree, the height is the height of a binary tree is logarithm log n, right? So we already know. So if there are n elements, the height of a binary tree is log n. So we have already seen it many times. So if you recall, you will understand. And again, so for this log n, what is happening here? I am so from the root to leaf, what is the longest path? The longest path is actually log n. That is, if there are 16 elements. So if there are 16 elements, there can be at max four nodes from the root to leaf. So here 1, 2, 3, 4. You can see. Now to initialize the tree, what is happening? I need to traverse all possible paths, right? So actually for every node, so we can say that for every node, I need to go log n time. So actually for every leaf node, I needed to go through this path, right? So to calculate this one, I needed to traverse this whole path. To calculate this one, I need to traverse this one. So actually, if you understand the process and if you think carefully, what is the total number of elements? It is n. So the overall complexity to build a segment tree here is order of n log n. Okay. So just to summarize, so what does this log n comes from? So the log n is coming from the height of the tree, and actually for each of the nodes there are n leaves. So for each of the n leaves, I need to calculate. So I'm assuming that I need to go through the whole tree from the root until that leaf. So that path is log n, and I need to do this n times. So this n log n. So if there are more questions, please put it in the comment section. So the next lecture will be based on how to make some queries in the segment tree and how can we update the segment tree from time to time, and what are the complexities for this process. So I hope this video was clear. So please, if this video was okay, and if you have some questions about this one, please put it in the comment section. Thank you.